Okay, welcome back. So we ended our last lecture with, through heroic efforts, developing a market equilibrium for avocados, right? We had demand equal to something like 800 over P. And we had perfectly elastic supply equal to, right, anything from 0 to infinity when we have a price equal to 8. Right? So we said our market's going to be in equilibrium when we're producing 100 pounds of avocados at a price equal to 8. So what we're going to do now is we're going to complicate this story a little bit by asking how this changes if we can't hire as many workers as we want as an industry at a wage of $16 an hour. Right? What these demand and supply curves are assuming, particularly what the supply curve is telling us, is if our wage rate equals 16, and our rental rate of capital equals 1, and our production technology is 4L to the 1/4, K to the 1/4 minus 4, then we'll produce as many avocados as you want at a price of 8. The issue that we want to consider in this lecture video, though, is what if we also have a market for labor? And what if the number of people willing to work in the avocado industry depends on the wage being paid? Right? So what if we had a labor supply that depended on wage? Well, we know that our demand for labor is going to depend on production of avocados, right? The reason people are being hired to grow avocados is to grow these 100 avocados. If we had a change in the wage rate or a change in the number of avocados we want to grow, that would affect our demand for labor, right? So in addition to our upward sloping supply of labor, we're also going to have a downward sloping labor demand that's going to depend on our wage rate, holding the number of avocados grown constant, right? So at any given moment, if we're freezing this, we're going to say our labor supply tells us how many workers are willing to, are willing to work at a wage of W, and our labor demand is going to tell us how many workers are the avocado fields going to hire, given that they want to produce 100 avocados at a wage of W. Cool. So let's imagine we start off, right, with everything in equilibrium. So let's ask the question, what would happen if we increase demand for avocados? Let's say people discover that you can put them in smoothies, right? Influencers start eating a lot more avocados. We end up with a demand equal to something like 1,600 over P. Numbers aren't important, right? The point is just it's more. If we take this graph literally, right, we would say, well, our supply is just anything you want at a price of 8. So all that would happen, our price would stay constant, we would increase our demand for the number of avocados consumed. Right? So far, so good. Supply equals demand again. But if we're going to now grow 200 avocados instead of 100 avocados, what's going to happen to our demand for agricultural workers? Well, we know, right, at a wage of W, right, holding the wage constant, we know that each firm was going to hire something like 1/8 of a worker, right? When there were 25 firms, their demand was 25/8. If we doubled the number of avocados being grown, we would have to increase labor demand. Right? We would actually increase it so that at a wage of 16, right, we would have twice as many workers demanded. But that's a detail. The important point is we've increased labor demand. Because we've got an upward sloping labor supply curve, the result would be a higher equilibrium wage. Right? Workers would get paid more because there's more firms chasing after workers, and there aren't an infinite number of workers willing to pick avocados at a wage of 16. Cool. So what's that going to do to the supply of avocados? We could supply as many avocados as we wanted at a price of 8, given that we had a wage of 16. But if we have a wage that's higher than 16, the price at which firms are going to break even is going to end up going up, right? So we have demand increase like this. Demand increases like this, right? The higher wage is going to result in supply of avocados going down, right? For a wage of, let's say, 20. What happens when the supply of avocados goes down? Well, we're going to have a higher price, and we're going to have fewer avocados demanded, right, on our new demand curve. Which, of course, means that our demand for agricultural workers is going to shift back a little bit, right, and our wage is going to fall a little bit. So the point is, right, when these two markets are interacting with each other, each change in this market results in a change in that market. Each change in that market results in a change in this market. We're only going to really reach an equilibrium, right? Only reach a point where there's no pressure on either of these two markets to have wages or prices change and quantities change when both the labor market and the avocado market are in equilibrium. In other words, when we end up with a combination of a wage, a quantity of avocados, a number of workers, and a price of avocados, where supply equals demand in the avocado market and supply equals demand in the labor market. Cool. So our goal here, right, is to have both of these markets be in equilibrium, right? To have a combination of price and quantity of avocados and wage and number of workers, where both our avocado market and our labor market are in equilibrium when we consider the link between these two markets. So just to be a little bit organized, right, what this basically means is that we need our supply of avocados, which is going to depend both on the price and on the wages, to equal our demand for avocados, which depends just on the price, right? We're going to assume for now that the wage of agricultural workers doesn't affect the demand for avocados. We're selling to a totally different group of people than are picking the avocados. And that our labor supply, which depends just on the wage, is going to equal to our labor demand, which depends on the wage and the number of avocados we're growing. Cool. And what do we know about these functions? Well, we know that our quantity demanded for avocados is just 800 over P. We know that our quantity supplied, I'm going to make this assertion. We solved this for a specific wage, but if we'd solved it for a general wage, we would have gotten 0 to infinity and infinity at a price 2W to the 1/2. Right, so when we had a wage of 16, this was 2 times 16 to the 1/2, it's a price of 8. Cool. And then labor supply and labor demand. Let's assert that we have an upward sloping supply of labor for avocado growers. Let's pick something really, really simple. So let's just assert labor supply equal to 32W. And then let's take a minute to try to figure out our labor demand. So to find our labor demand, right, we're just going to use the work that we've already done to learn how many workers each firm is going to hire at a wage W, and then how many firms are going to exist given the total output in the avocado market of Q. And again, I'm going to make some assertions, right, about how what we did in a specific wage is going to differ when we solve for a general wage. You can go back and find and prove this to yourself if it's helpful, and that could be good practice, but I'm not going to spend too much time doing that algebra, because otherwise our heads are all going to explode. Okay, so what we said, right, is that an individual firm is going to hire labor, L of Q, equal to, what was it, Q plus 4 squared over 64. If instead of using a wage of 16, we used a generic wage, this would be over 16W to the 1/2. Great. So this is the number of workers that are going to be hired when when that firm is producing little q units of output. We can also say each firm is going to produce little q equals 4. Right, we got that before. It turns out this doesn't depend on wage at all. So as a result, each firm hires, right, L is going to equal 4 plus 4 squared over 16 W to the 1/2, right? So 8 squared over 16 is 4 over W to the 1/2, right? Right, so each firm is going to hire 4 over W to the 1/2 workers. So then the question is, right, how many workers is the industry going to hire when we're producing Q units of output? Well, to do this, we just need to know the number of firms, right? Multiply the number of firms by the number of workers. So the number of firms is going to be big Q, right, total output, over little q, output per firm, right, is going to be big Q over 4. So the total demand for workers in the industry as a function of W and Q is going to be 4 over W to the 1/2 times big Q over 4, which is of course just going to be big Q over W to the 1/2. Great. So we can finish our set of supply and demand curves here by saying that our labor demand as a function of W and Q is just going to be big Q over W to the 1/2. Beautiful. Okay, so now we've got our labor supply and labor demand function, right? We've got our product supply and our product demand function. So where do we go from here? Well, what we can do is we can essentially say, we can use the equilibrium in one market, right, in the labor market, to figure out our wage as a function of Q. In other words, to tell us, right, when we've got Q units of output being produced, and therefore labor demand of Q over W to the 1/2, right, and a labor supply of 32W, right, this can tell us, given some Q, what's our wage rate going to be. Once we have that, we can replace W in our function here with our function of Q, right, in order to tell us in our product market, right, in our product market, what is our labor supply just as a function of P, right? Taking into account the effect of our output level on our wage rate. Okay, makes sense? So we're going to start using equilibrium in our labor market. So to do that, we'll set labor supply equal to labor demand. So we'll say 32W has to equal Q over W to the 1/2. Right? From here, we can multiply both sides by W. 32W to the 3/2 equals Q. Right? W is going to equal Q over 32 to the 2/3. Make sense? So what we're doing is we're saying that by setting labor supply equal to labor demand, we can tell that our equilibrium wage here is going to be Q over 32 to the 2/3, right, as a function of Q. This means as we demand more output, our wages are going to increase. As we demand less output, our wages are going to decrease. Awesome. So from here, we can adjust our labor supply, right? So from our labor supply, we know that price is going to equal 2W to the 1/2, right? I'm sorry, from our quantity supply, right? So we can plug in Q over 32 to the 2/3 into our quantity supply function, right? So we can say P is going to equal 2 times Q over 32 to the 2/3, all to the 1/2, right? The 1/2 and the 2 cancel. So this is just going to be P equals 2 times Q over 32 to the 1/3, right? Our goal is to get a labor supply function. So we want Q in terms of P. So we can solve this by dividing by 2, cubing both sides. P over 2 cubed equals Q over 32. Right, from this, we can say the quantity supplied as a function of P is going to equal, right, 32 times P over 2 cubed, or, to simplify this a little bit, right, 2 cubed is 8, so this is going to be 4 times P cubed. Awesome. So let's take a moment to reflect on what we did. Right, what we did is we said, given a quantity Q of output, our wage is going to be Q over 32 to the 2/3. Then we said, as a result, if we want to think about our quantity supplied, not holding wages constant, but accounting for the ways that quantity changes are going to affect wages, we find that quantity supplied as a function of P is going to be 4 times P cubed. Right? This function here is going to be 4 times P cubed. What does this mean? It means that our new supply curve, right, QS equals 4P cubed, is no longer holding wages constant. Instead, it's holding the labor market as a whole constant. In other words, what we're saying is, how does our quantity supply change as we change price, assuming that we still have a labor supply equal to 32W, and we still have, right, our production function, our rental rate, all of the other inputs into our production decision constant. Right, instead of holding W constant, we're holding labor supply constant. Awesome. So now, all that's left to do, right, is to solve our competitive equilibrium in our product market. Right, we know that our quantity supplied is 4P cubed. We know that our quantity demanded is 800 over P. So we just need to set supply equal to demand in the product market. Right, so quantity supplied as a function of P has equal quantity demanded as a function of P. Right, so 4P cubed equals 800 over P. Right, P to the 4th equals 800 over 4. Right, P is going to equal the 4th root of 200, which is about $3.76. Right, so we're going to get a price here of about $3.76. Awesome. And now we're basically done, right? All we have to do now is unravel this problem backwards. From our price, we can find our quantity. From our quantity, we can find our wage. Right, from our wage, we can find our labor demand. Cool. Right, so we can say now that we've got a price of $3.76, right, our quantity is just going to be 800 over P, right, which is going to be about 212. Right, our wage is going to be our quantity over 32 to the 2/3, which is going to be about $3.54 an hour. It's a pretty bad wage for farm workers in this economy. And then our labor, right, our labor supply is just equal to 32W, which is going to be 133.14. Right, so what we're saying is, when we have a price of $3.76, when we have a wage of $3.54, we're going to have a competitive equilibrium in both markets, where we have 212 pounds of avocados produced, right, and we hire 133 workers to grow those avocados. Okay, so this is a ton of math. So I just want to take a second to recap what we did. Effectively, what we did is, we started with supply and demand equations in both of these economies, right? But our supply of avocados depended on the wage of workers, and our demand for workers depended on the number of avocados we needed to grow. So what we did is, we used competitive equilibrium in one market, right, in the labor market, to find our wage rate as a function of quantity, right? As a result, we could replace the wage rate in this economy, right, in our product market, with a function just of Q, so that our product market was just a function of P and Q. From there, we could solve the competitive equilibrium in our product market. Okay, beautiful. Thank you so much for sticking with me. So, going to be the approach that we're going to take to any of these questions, right? Regardless of the way that our markets are linked together. We're going to use one market to essentially solve our links, right? Then get an equilibrium or general equilibrium adjusted supplier demand curve in our other market, and then solve the competitive equilibrium there, right? So we replaced a supply curve here that doesn't take into account market linkages with a supply curve that does. Okay, awesome, thank you so much. In the next video, we're going to talk about markets that are linked through demand rather than talking about a link between a product market and a factor market.